Right, hey guys, my name is Junha Park. I'm working on FastRoll, which is a Rust implementation. Previously, the name was RGem, Rust plus Gem, but as I introduced these to some of my PBA friends, I found it was hard to pronounce and remember, so I just rebranded it to FastRoll. I'll give you a quick intro to our team, share some implementation progress and future plans. So this is a brief timeline that shows the FastRoll journey. So I'm the only one in the team. Previously, I worked at Aptos Labs as an engineer. March in 2024, I first got to know about Polkadot. I was doing some market research, comparing different blockchain networks. And then I figured out that Polkadot has a very outstanding Nakamoto coefficient, which means that it has a very actually decentralized, high degree of decentralization. So I got a little bit of interest in Polkadot. And then in June, there was a great paper tour at Seoul National University, which is my hometown. So I first learned about great paper and Jam at the time, and I started reading the paper for like 1 or 2 months. And then after that, I understood it a little bit and then started implementing. In November of last year, Sub-Zero Bangkok, I was there. I could meet some of new implementers. And in March this year, so I've been working on Jam. I kind of understood great paper, but I didn't know very much about Polkadot ecosystem and all the backgrounds. So I wanted to learn more in depth about Polkadot. So I joined PBA's cohort 6 in Switzerland. Yeah, so from there I could learn some background knowledge about how Jam is here today, and then a little bit about Alps, Grandpa, and even FastRoll, which are backbone of Jam. And then after completing the PBA, I decided to resign from my previous job and become a full-time jammer. So now I'm yeah, so after that, my life became a lot simpler and more fun. Just focusing on one very exciting thing. Then in May, right before I come here, I just renamed the client to FastRoll. Then to share some progress, I wrote most of the library code required for Awesome 1, like passing most of the public test vectors from Web3 Foundation and Dave XY repository. I think it's around 450 to 500 vectors available. And current focus is to write down the node binary. So until now, I was focusing on writing of the library. And now I'm writing the node binary for blog importer. So actually becoming a user of the library I've written for the last few months. And then basic GemNP for blog announcement and blog requests, which might be useful for demonstrating blog import. So yeah, trying to write the node binary for basic author and importer roles. And then I figured out that actually trying to write the node binary is quite useful to get some refactoring ideas for libraries, because just writing code for libraries is quite straightforward, just implementing what the gray paper clearly states. But as I put them together and try to make a node run, I figured out that sometimes I have to think about the state transition functions ordering. At some point, I have to predict the post state even before actually running the state transition functions, and needs some more types and better abstraction to be usable by the node. So yeah, that is one kind of pillar, trying to put the library code together into a node binary. And then another one is to achieve a higher coverage of my milestone one for the milestone one code. So currently I have like 70% of the coverage, and I hope at least for all the lines they are covered by my test for different scenarios. And I also want to add some more own test cases, so not just only depending on the Web3 Foundation test cases, but just want to write down some inputs and outputs directly from the gray paper and then test it by myself. And this is also one idea I've been thinking recently. So the problem was that I found out that there are like 250 equations in the gray paper when it's rendered. And then I wanted to become extremely confident that my implementation actually implements all those equations and runs all those equations at least once during the test run. It was a bit tricky because it cannot, as far as I imagine, it was very hard to be automated because we have to anyways inject the gray paper knowledge to do some coverage. And then also the equation numbering was updating quite frequently, so yeah, I just had an idea for a while. I couldn't actually implement this yet. So basic idea is like this. First of all, label all the gray paper equations with some tags. Like some equation is state transition functions, some are utility functions, some are type definitions or constant values, and then produce a simple JSON output. I think this should be done manually. And then annotate the actual implementation code with comments. So I'm planning to use the comments because I don't want to make my code dirty just for this one. And then run tests with existing coverage tools like GR code or Cargo LLVM code for Rust in specific. And then after running the coverage measurement, parse the source code where I put the comments, annotating which equation this function implements, and then also extract the code coverage report, and then extract line number info, and then compare it with my annotation to measure the gray paper coverage. So the image below is the ultimate form that I want to get in the end. So list out all the equations, and then categorize them, and then check if how many of them are implemented and how many times each of them was executed during the test run. Another alternative was to just wrap the functions or statements with macros and count how many times they were executed, but right now I'm leaning more toward the comments approach. So I just tried to do some manual labeling just for FastRoll. So there are security functions, some constraints like that. Then in the actual implementation, just add some comments with certain format, so it could be parsed easily afterwards. So this is just an idea. This is not my top priority right now. So maybe once gray paper gets more stabilized, I could try this. I also want to hear other teams how they are dealing with this, or they don't care very much about this. So yeah, I want to discuss about this throughout the conference, this Junha XP. And then here's future plans. So in May, I hope I could complete the importer role and then some basic networking and do some last major refactoring before the M1 submission. And in June, more coverage test. And after that, I have to implement the erasure coding, data lake EA, and then think about some strategies as importer or author or importer node, and also implement all the other rules, guarantor, assurer, and auditor. So after that, I hope I could test more fun stuff with real programs. Possibly try Doom as well, but maybe after June. So yeah, that was a brief update. Here's my social, so let's connect. Thank you.